The area of the triangle ABC is 3 root 3 meters squared. Calculate the value of x for 5 marks. We know area is the inside of a 2D shape. As we're told, the area of the triangle, in this case, is 3 root 3 meters squared. We know the formula to calculate the area of a triangle is a half AB sine C. All we need is 2 sides and the enclosed angle. Look at my diagram. I have 2 sides. I have the length here on the right and the length here on the base. And sine of my enclosed angle, in this case, my enclosed angle, i.e. the angle between those two given sides, is 60 degrees. Hence, substituting into my formula, I'm going to have a half multiplied by A and B on my 2 sides. Hence, I'm going to have x plus 3 multiplied by x minus 1 in any order, multiplied by sine of the enclosed angle. In this case, sine of my enclosed angle, the angle between the 2 sides, is 60. I know in this case the area of the triangle is actually equal to 3 root 3. Leaving the half alone, expanding out my double brackets, I know that x times x will give us x squared. I know x multiplied by negative 1 will give us negative x. I know positive 3 times x will give us plus 3x. Well, 3x subtract single x will simplify to give us plus 2x. I know that 3 multiplied by negative 1 will give us negative 3. I should know that sine of 60 is an exact value, which is root 3 over 2. And on the right-hand side, it's still equal to 3 root 3. Simplifying the left-hand side. Well, on the top, here I have 1 multiplied by root 3, which is simply root 3. On the bottom here, I have 2 multiplied by 2, which is 4. And it's still multiplied by x squared plus 2x minus 3. And on the right-hand side, it's still equal to 3 root 3. We never like dividing. The opposite of divide by 4 is to multiply both sides of our equation by 4. On the left-hand side, times by 4 and divide by 4 will cancel. Hence, we're just left with root 3, lots of, in brackets, x squared plus 2x minus 3. And on the right-hand side, I know that 3 root 3 times 4, if it's outside, it times the number outside. So 3 times 4 gives us 12 lots of root 3. We know the opposite of multiply by root 3 is to divide both sides of our equation by root 3. On the left-hand side, root 3 over root 3 will cancel. That'll just leave us with x squared plus 2x minus 3. And on the right-hand side, I know that root 3 over root 3 will cancel. Hence, we're just left with number 12. I can now see I'm getting a quadratic in terms of x. As I'm trying to solve for x, I want my quadratic to equal to 0. As my quadratic currently equals to 12, to make it equal to 0, I'm going to bring the 12 across the left-hand side. If you move a term over an equal sign, it changes sign. So the opposite add 12 is subtract 12 from both sides. On the left-hand side, I'm now going to have x squared. I've still got the plus 2x. Negative 3 take away 12 will simplify to give us negative 15. And on the right-hand side, 12 take away 12 will cancel. So it leaves it with 0. As I'm solving a quadratic, 3 terms are going to factorise into what we call double brackets. As the quadratic starts x squared, each bracket will start with single x. My rule is I need to find 2 numbers that multiply together to give us a number term, in this case negative 15. And the same two numbers must add to give us a number in front of the single letter, which in this case is positive 2. The only way to get a negative when multiplying is to have 1 positive and 1 negative. The factors of 15 are 1 and 15 and 3 and 5. Hence, in this case, my pair is going to be 3 and 5. As need to add to give us positive 2, therefore the plus has to meet the 5 and the minus with the 3. As we're solving for the letter x, I now place each single bracket separately equal to 0. Taking my first bracket, if I place x plus 5 equal to 0, as I'm solving for x, the opposite add 5 is subtract 5. So one solution is x equals negative 5. Placing my second single bracket, x minus 3 equals to 0. Again, as I'm solving for x, the opposite of minus 3, therefore it goes across an equal sign, changes sign, therefore is plus 3. When you solve a quadratic, you should get 2 solutions. But in this case here, we're asked to find the value of x. There's only one solution. As we know x is a length, therefore in this case we know x cannot equal to negative 5. Otherwise we'll have a negative length, which cannot happen. In this case, x must equal to 3.